Welcome to From Pipelines to Cloud, Mastering IaC with Azure DevOps. I am Adam. So today's agenda, I'm going to do a quick review of some of the stuff I covered last time. I'm going to do a demo showing Azure DevOps and Pulumi and Azure together. And then we'll have a little bit of Ask the Expert time. So when I was putting together this workshop, I had to Google some things. I got to be honest. Azure DevOps is not my area of expertise. And some of the information I found was from this great person named Zac Cook. And lucky for me, he recently started working at Pulumi. So yeah, Zac, how would you, what's your 60-second bio?
Been around in DevOps space for a very long time. I have started with this, from a young age, Commodore 64. So I kind of bounced between development and business and systems. And so now kind of this day and age with the cloud sort of encompassing all of that, I feel really well positioned to be kind of in the infrastructure and pipeline space.
That's awesome. Yeah, and your article was helpful on OIDC for me. So last Azure talk, what I did was I had a C# program locally, and I wanted to get it running in the cloud as a service. And so I wanted to use C# to do that because I wanted it to be, a language I was familiar with. And I just like C# and it was an Azure talk. So I think it made sense. And so we got all that working. We got the infrastructure set up to run my dad joke service in Azure. So today we're taking the next step, right? I want to set up a deploy pipeline so that I can make changes to my function, to my C# code, and then, I'll have a PR review process, and then I'll deploy that automatically. Yeah, so this, I'll show this in a moment, but this was my dad joke CLI. You can, give it a keyword and it does a dad joke. It's using OpenAI behind the scenes. Why did the .NET developer go broke? Because he lost his cash. So the jokes are not necessarily funny. I don't know about AGI is coming because there's work to be done there. But what I did was we moved it into Azure like this. We set up a function app running in Azure behind a specific URL with this API joke. And so when you made a request against that, we also set up an OpenAI Cognitive Services subscription, and we would make a request against that with our query, like write a dad joke and then get that back and return it to the user. So that was kind of our simple infrastructure. And the way that worked was with Pulumi, obviously. So we had our program.cs, which described our infrastructure. And then, when we do like a Pulumi up, it will look at our Azure account at the current state of our resources, compare that to what's desired based on the declarations in our program.cs. And then it will do a create, read, update, delete to put those changes into place, right? So that's our basic IaC model. We are using code, but we're describing like a declarative state, and then we're comparing that to the cloud and making those changes. Makes sense, I think. I also covered last time, like a reason that you might want to use Pulumi is the ARM templates are incredibly verbose. So this was just a very simple example of setting up a storage account. And in ARM, it was a little hard to read. You can use Bicep, which is a bit better, but it's still pretty verbose. So I think this is one of my sales pitches for Pulumi is just like, it's C#. If you like C#, then I think you're going to like it. Prerequisites before I jump into setting all this up, right? So we're going to need Pulumi. We're going to need .NET 8. We're going to need the Azure CLI. We're going to need Azure DevOps account, access to your Azure account, and a free Pulumi cloud account. So I've shared the code. The code has a tutorial.md in it. You don't have to follow along as we go. I'm just going to show kind of what is possible. But if you do want to do something like this in the future, we're sharing all those resources with you. But yeah, this is what I would like to set up. So we have our Azure DevOps account, and in that we have like our GitHub repo, in there we have our Git repo for our code for our dad joke service. And then we are going to set up a build pipeline so that when we make a change, then the Pulumi CLI will use Pulumi ESC to retrieve some secrets. Those secrets will be how you contact Azure, and then we will deploy that to Azure, and we'll be happy, right? So we don't need to do a Pulumi up on our local. We can do it in the cloud in our CI/CD. Specifically, this I think is a better description of the goal I want to get us to. So this is a problem I see a lot where there's an organization, they have an infrastructure engineer, and he's very busy or she's very busy, and they have a lot of work on their plate, and they become a bottleneck, and sometimes for good reasons, sometimes for bad. And I think one of the bad reasons that I see a lot is because nobody else understands what's going on, and they don't know how to contribute. And maybe the process is actually very ad hoc and is just done on Bob, the infrastructure guy's machine, and it's a problem. So what we're showing today is something better, right? It's just getting CI/CD in place around infrastructure. So we're going to have our infrastructure in C# so that if somebody wants to contribute, they can pull down that. They could make a change. Maybe they're just adding a simple bucket. They can push a PR, right? They push that PR to Azure DevOps, which is step 1. And then in step number 2, they'll get a Pulumi preview as part of that, which will have a diff, right? And we'll show, what's going to change here? Is this dangerous? Is this safe? That will get added to the PR. So then that can be reviewed by the infrastructure expert or whoever is involved, right? Who can then approve it and merge it if it's safe. And then those changes can be applied to prod. So that's what I want to build out today, because I think that this is a big enabler. You can kind of get some of these easy requests in a way where people can self-serve just using code. So let me show that. Perfect. So this is my Azure DevOps C# project. It is my dad joke function. So I have a bunch of folders. One is this CLI folder. So as I showed earlier, if I go to CLI, I can do nut and run, and that should give me a dad joke. Why don't skeletons fight each other? Because they don't have guts. We also have an infrastructure folder, which is the infrastructure that I was discussing before. So here we can do a Pulumi up, and we can set up this as a function in our Azure account. So we will roll that out. And that, as I showed, is, which way did I show? Like this, right? So we set up this function app so that we can make these requests. The actual infrastructure looks like this. We push a zip file. We push a zip file that the function app uses, and then that's going to set up our public endpoint. And we also set up our Azure account so that if I curl this, I should get a cloud joke now. There we go, because it was stuffed. So that is our infrastructure. And now what we want to do is set up Azure DevOps. So let me see, what's the URL here? So Azure DevOps, you probably are aware, this is Azure DevOps, and in it you can have various projects. We're going to set one up from scratch. So I need to name it test project. Yeah, and I'm interested in the chat. How many of you are using Azure DevOps as your source control, as your CI/CD solution, etc.? And if not, like, what are you using instead? But if you're using Azure DevOps, you are likely to have all your source in here. And so let's set that up. So I'm going to add this project to my Azure. I guess I need to push. I'm just adding it as origin 2 because I already have it set up in this other Azure project. So we're kind of duplicating it so that I can show you a nice demo. So here we go. Here is my code. Here is my README. All is well. Now we want to set up a build pipeline. So first thing we need to do, I should make this bigger, is get some credentials set up. So earlier when I ran Pulumi up, it's just using my local credentials, but now I want to run it in a pipeline. So I need to extract those and set them up in a safe way. So first I need my app ID, which is just how Azure differentiates what account I'm running under. Then I need to set up a secret. So you can see here, I'm using the Azure tool AZ. And then I'm going to create credentials that I can use here to push this, right? And so I'm just calling that new secret. I am not echoing that for you because I don't want you to have it. And then the other thing I need to set this up is I need my tenant and subscription ID. Okay, so with all of those, what I'm going to do, I could put these in Azure DevOps, but what I'm going to do is use Pulumi ESC. So Pulumi ESC is environment, secrets, and config, and it's just a great place to centralize your secrets and have them stored in a place that can be used by everything. So I will create a new environment here. I will call it Azure Dev. Oh, Azure Dev 2. Oops. I will create that. And so here in YAML, I can set up the secrets that I will need so that Azure DevOps can talk to Azure. So I'm going to do it like this. So here, I'll put that client ID that I got back. Here would be my secret that I did not show you, and then my tenant and subscription ID. And then Pulumi is going to be able to use that. I guess actually Azure DevOps will be using these environmental secrets to do the push to Azure.
I think that's some of the real strength of IaC is that you define it once, you put it in one place, you can get it as the environment variables, you can get it into Pulumi config. So your infrastructure program has whatever values it needs if it's related. But then at any point in your CI/CD process where like, okay, I want to drop into an actual CLI command, like run a build or inject the same config into my app. You know, if your dad joke function needed to use any resources that your infrastructure provisioned, you know, you can kind of have that all in one place, defined once, and then exposed as often as necessary. It's really, really nice stuff.
Yeah, I definitely agree. And actually, we do our dad function does use an API key to talk to the to talk to the OpenAI cognitive services. So that's a good call out, is that should be bubbled up here as well. So what we're talking about, what Zac is talking about here, I did a little diagram of it. So we have our Azure DevOps, which is using a Pulumi access token, and it's going to then, the Pulumi CLI is going to retrieve from IaC those secrets I just set up here. And then those are going to be used by Azure as well as by our service. Now, like while we're on this topic, you can see I put an asterisk here on Pulumi access token, and I also put an asterisk here on Azure credentials. Any guesses, Zac, why I have those?
No, go for it.
Okay, well, it's because they expire, right? So I think that right now the problem is I have set up this secret for the Azure credentials, but like this credential that I set up here has a certain expiry, And there's actually a better way to do this, right, with OIDC. So it's kind of outside of the scope of today, but it is possible to change this to be something like this, if you guys can see this. So if we, instead of using a Pulumi access token, which I set up in Pulumi and say how long it expires for, it's possible to set up an OIDC relationship where Azure DevOps will actually, on each run, talk to Pulumi, kind of authenticate against it, and get back a short-lived token, which I guess I have marked out here, which it will then use. And you can do the same with Azure. So Azure can have a OIDC relationship with Pulumi. So when I get that Azure credential, I get a new one each run, and it has a short time span.
Now, to elaborate on this, as well as go back to chat, you know, some folks were talking about they're answering your question about what they use Azure DevOps for. You know, some only use it for pipelines, some use it for project management, but not pipelines. So that's one of the interesting things I think about DevOps is that that product has got a lot of very easily siloable parts of it. So you can use it as a Git store, or you can use it just for CI/CD or just for project management. So that inherently has this multi-cloud relationship, which OIDC makes significantly easier, right? Because like now I have short-lived tokens not just between Azure DevOps and Pulumi Cloud. I have short-lived tokens between Azure DevOps, Pulumi Cloud, Azure DevOps, GitHub, you know, whatever, wherever all your source can live in GitHub, while your project planning lives in DevOps, while your CI lives in DevOps, or, you know, any combination thereof. OIDC makes those cloud relationships just very, very natural, right? And all short-lived tokens and actual, you know, it's like the most secure way. But then you also don't have this situation where with like personal access tokens and things of that nature, where it might be tied to a specific user, or, you know, there's that annual event of like, I have to remember to refresh the token because it'll expire soon.
Yeah, that's the one I was thinking about, is like, okay, we have all this various relationships set up, and then something expires, and all of a sudden we're in trouble. Exactly. No, I totally agree. Okay, so now that we have ESC set up, what we can do is something like this, right? So this was the environment I set up, Azure Dev. And so now just to test it, I'm now running my Pulumi preview inside of that environment. So instead of using my local credentials here, I should be pulling from there. And you can see that that preview worked. We can also do an up. And so this was what Zac is talking about. We've moved all of our environment into this that we can use wherever we need it. And it worked. Okay, well, that's good. Okay, so now we have that environment. Let's start setting things up in Azure DevOps. So we're going to go to pipelines. We go library. There we go. So I'm going to create a variable group. The name of this is actually important. In that I use the name later on, so I need to make sure I get it right. And so here, I'm just going to use a Pulumi access token. So this is not the OIDC. And so eventually this will expire and should be updated. But I think it works great for a demo. And then I'm just going to drag this off screen to put in my actual token, because, I mean, I'm sure you're all trustworthy people, but I just like to be careful. I'm going to put my Pulumi token in there. And let's save that. Drag that back. Okay. So this we're going to use to tell it which credentials to pull. So it's nice to have these here in case we need to switch it at some reason. This is just how we're going to talk to Pulumi. And then we need to, how do you do this? Open access. So we need to allow our pipelines to actually read those values. And then we're going to create some pipelines. So I actually have created them here So this is my first pipeline, which is my deploy pipeline. So this is in the repo, and it's very possible to do it through the UI, but I'm just going to use this pipeline create command to create it. And then I have this preview one, which is here, that I'm going to use on PRs. So I create that one. Then let's see. Now, okay, so this step probably depends on how you're using Azure DevOps. So if you actually have your source control in GitHub, for instance, the way that you might trigger these might be different. But what I'm going to do is I'm setting up a policy. So if your source is not here, you can set up, I believe, the triggers right here. But since I have my source in Azure DevOps, I set up a policy here. So what this policy says is that my main branch is protected, and that if I have a PR against it, I'm going to run this PR repo.
It's out of scope for the demo, but just calling out that there is an Azure DevOps provider. So if you wanted to do this with Pulumi IaC itself, you could actually do it that way too.
Yeah. I actually have, so I've actually built here in this repo that people can take a look at what I called meta infrastructure. So here I have a project. We won't have time to get into this, but this is a Pulumi program that uses the Azure DevOps provider to set up a lot of what we're setting up here. So yeah, good call out. Okay, so now we have these two pipelines, a PR and a deploy. And so let's do something, right? So I'm going to set up a test branch. And then if I go, so I want to go to my function and make a change to it. So this is my joke function. Maybe if I turn the temperature down, maybe I'll get better jokes. So I'm going to commit that. And then I'm going to do a git push origin 2. Let's see if that works. So if I go here, we can see, oh, we got a new branch. So here I'm simulating, the person who wants to make a contribution to the infrastructure can now do that, right? We can review those changes. I guess in this case, I'm actually changing the code of the service rather than the actual infrastructure, but I think it applies either way. And you can see here our PR build is, let's click into it. Here we go. So here's our Pulumi preview. We can see that because I'm on the free plan of Azure DevOps, it wants me to wait a moment. 7 queue time variables used. Agent is not running because potential. Okay, well, it should run it. I'm pretty sure. We just have to wait. But there we go. Things are happening. So there's nothing too mind-blowing in our pipeline. What it's going to do is install those prerequisites that I went through and then run a Pulumi preview. You can see that we are using our IaC environment right here and selecting our stack, stacking it, and then here is our preview. And we're returning a diff. And let's see what we get. Right, so here is our diff. So based on that change, here are the things that it needs to make changes to in the infrastructure. One reason I think this is so important, right, is you can look here and see.
There's a call out in chat that the font's pretty small. I kind of agree. If you can zoom in.
Yeah. Is this better?
Yes.
Okay. So now on our PRs, right, we can see what the infrastructure changes will be. And if we're adding or updating things, that's generally safe. But when you see a replace, right, that's something to think about. So actually, the way that we have this function set up, every time we make a change, it is going to pull it down and put a new one up. It does it pretty fast. Like you could see when I did the up is like 11 seconds, but that does represent some downtime. So something to think about for your SLOs. But that's why I love this process, is because you can see right in the PR, right? Are we going to have some impact, and how do we think about that? So for this particular case, let's go back to our PR. Pull requests. Let's say that's good. And we are going to merge it. And that should start our deploy PR. If you recall, let's see if I have this diagram. Let's zoom in on this. So this is the process we're working on, right? So we pushed a PR, we have gotten the review back. Looking at this diff, we have decided that it is okay, and we are doing an approve, and we're pushing that to prod, right? So now our Azure DevOps is going to run that deploy pipeline, and it's going to put those changes in place. So let me see here. I go to pipeline. Here's our deploy. We can see it's running. And so that's like our CI of our CI/CD. And here we have the actual CD. We're actually going to deploy with Pulumi this change, so that now our function, once that runs, will have the new temperature setting. An interesting question, though, that I had, right, is, well, if I was doing this with Kubernetes or something, it's very easy to make this change with zero downtime, because you have kind of rolling updates. We'll start a new container, wait till the health check is up, and then switch over. But as you could see, here we're doing a replace, and so there's some small downtime. So it is possible to make the Azure functions work in a zero downtime way if you use Pulumi hooks. You can kind of set up a blue-green type scenario. So right now we have one function app, and we have just this generic function app.zip. If we want to move this, if we want to have zero downtime, we can easily change this, right? Like this is a great demo rollout, but probably we actually want, instead of a generic zip, to actually make releases. Maybe we give these version numbers or a git hash. And then each time there's a new release, we make a new git hash, we put that into storage, and then we can kind of follow this blue-green process where we have Pulumi. So we have something at the front that directs traffic either to one or two versions of our function app, either blue or green. And then Pulumi will actually check which one is active and then make the change to the other one. So here it is basically, what's the ordering here? So if blue is active, for instance, it will push out the blob change to green. It will run this health check. And then once the health check passes, it can switch this over to here. And that kind of gives you a way to do kind of what you get in Kubernetes for free, but on top of a function. So that would kind of look like this. Kind of a side topic, but I think it's pretty interesting. So you kind of detect which of your two functions are active, deploy to the other one, hit the health check, and then you can route back to, you basically switch it over. And the reason you can do this is because of a new feature called Pulumi hooks, like, I mean, relatively recent. I think it's pretty cool. So back here at our deploy, where is our deploy step? So we're installing, here we go, deploy with Pulumi. So here we can see there was one update to our storage, one replace on that function, and it rolled out. And so we should be able to call our updated version. But I think we already saw this joke, which I can share this with the chat. Where's my big marker tab? Here's the URL. So where were we? See, I got too many windows open here. Back here. Okay, so this rolled out successfully, and now, right, in our repo, we now have that change in place. So basically what we have done, sorry, too many slides. What we have done is set up this process, right? We have our repo with our C# solution and our infrastructure in it, and now it's easier for people to contribute changes, not just to the underlying service, but actually to the infrastructure, right? If we need a new storage thing, if we need to make changes, it is just in C# code. It is in code they can understand, they can contribute, they can put together a PR. Where did my visual go? Lost it. Yeah, so people can submit changes and they can be reviewed and then automatically rolled out. And I just think like this is very basic. There's a lot that we can improve on from here, right? We can add OIDC, as I mentioned. We can move to have a more zero downtime setup. But I think that having something in place like this, basic CI/CD with infrastructure, right? With a PR process, a review, using the Pulumi preview to see what changes can be done, and then rolling it to prod. This is so important. So many people bottlenecked because they don't have a step like this involved. I was just talking to somebody recently, and like all the infrastructure changes were done on Bob's machine, and there's a new Bob now, and he's having trouble setting things up, right? He can't get the same process working because Bob number one was just always the person who did this. If you like, even if you don't want contributors, right? Even if you want to own all the changes to the infrastructure, I think that having it run in a pipeline where everything's set up, where all the credentials are in place, is just a good idea. And this is just the basics of that, right? We can go further, right? Like you may want to have a staging environment. You may want to have the same process, but things get rolled out to staging. People take a look, make sure that infrastructure is actually working, and then it gets moved over. But I think this is the basics. And once you get that right, you can layer on everything else. There's a lot more to you can set up. I just hear Zac cutting in. Question?
No, I was just answering in the chat. There's a couple of things about hooks and whatnot. To layer on this, right? That CI process, the runtime, different stages. Okay, deploy stage, deploy production. What's really cool is that with some basics, with some CLI stuff, you can actually kind of cut in and out of those Pulumi programs depending on if you wanted to structure your same program, but you wanted distinct stacks for each level of environment, right? Your CI step can, like you can use a Pulumi output for a URL, for that blue-green, for anything like that. And then the next promotion step, that Pulumi program can even have some of that information. Like you can kind of weave that in and out of your Pulumi's programs and your runtime environments and your CI, however it makes sense.
Yeah, you can also build components. So you can say, hey, we're doing this function thing a lot. Maybe we can abstract that into something that's easier for people to use, pull off the shelf, right? You can build a whole platform, which I think, Zac, you've done some of. You can build a lot on top of this, but I think like the real cool thing to me is just like now people can participate. It all makes sense. It's all in code. We have this nice process that we can work through and review. I don't know. I think it's magical. That was the big thing that I wanted to get across about how to set this up, right? So we've now taken an Azure setup, and we have our pipelines running, applying code. We have our environment set up. Our environment is actually coming from these credentials that we're pulling in from ESC. which we have here and is easy to change and easy to version. It's just a lot of basics, but just, in place in a way that really makes sense. Okay, let me go back to here. Let's stop sharing my screen. Let's go to my slides. Okay, so as I mentioned, we have a lot of resources that you can draw on. All this code is available, but you can build on this to add other things. And I also included a link to Zac's great article on setting up OIDC. But now we have Zac here. And so I wanted to make sure that we had some time to hear from an expert like yourself, Zac. So I have some questions. I don't know, is there any user questions that you think are interesting, or just start with some of mine?
Give a minute for folks to pitch in. I want to roll up to just a comment that was in chat about kind of hoping this demo focused a little bit more on the Azure DevOps provider. So just to reiterate, you do have that meta infrastructure part of your project. So that isn't what's that's shared, right? So even though that wasn't reviewed expressly here, basically the things that were run via CLI are things that are possible with the Azure DevOps provider. So you can get the same thing we demoed with a purely Pulumi ESC solution.
Yeah, so I included in the source, there is a folder for Pulumi infrastructure. Sorry, it's the meta infrastructure folder. Uses the provider to set up. It sets up a new project. It sets up new Git, and then it sets up some pipelines. Mm-hmm. So that. Sorry, go ahead.
That's super worth reviewing. Just it doesn't necessarily fit into a compact demo like this. So the practical experience I have with that provider is I've created like a Pulumi pipelines project where it literally all it does is take an array of this Git repo, this GitHub repo, this Azure DevOps project, this pipeline file, and it creates that. It permissions that. It adds the runner's ability to do that. It can add gates like it can add environment locks. All of that's there, and then that basically makes it where there's a dedicated infrastructure project that maybe you only want certain DevOps engineers, or a slightly smaller subset of basically creating those pipelines in the first place. So that's all possible with those providers. It just doesn't necessarily fit into here we're deploying a Lambda function. Like we're almost it's two different things almost in most workflows, I'd say.
Yeah. So how, in your experience, like how did you find, were most pipelines the same to a certain extent, or was there a lot of differentiation between them?
There's a same, very similar setup in pipelines for the most part. So and every provider kind of has every like CI/CD provider seems to have a different approach to this. So for GitHub, you have to be GitHub Enterprise before you can set up like an organization level policy for, I always want a develop branch, a main branch, and I always want these rules about this group can promote to develop and not main. And you have to either create like a template repo or have a license where you can set that up on the org level. And so one of the ways that we've kind of standardized that in other projects is we'll take like a provider repo that creates these rules, and we'll use the Pulumi providers to create the new GitHub repo, the new branch rules, the new permissions rules, like all of that stuff that you can get there in other ways, but you get a little more control over that. And then that way, if you do have a project that's like slightly different, this is a front end only project, this is this project, we want different rules or different restrictions on who can push front end changes versus back end changes or database changes, and that all kind of goes into, you can kind of start to imagine that being like groups in your pipelines project, where like this is stateful projects, this is front end projects, this is back end projects, and we're going to create those teams. We're going to manage membership. You can kind of do anything you want, which gives you like that consistency across an enterprise without necessarily having to do it as a config in a settings page somewhere on one of these providers.
Yeah, it can be. You can do a lot, right? You can kind of build your own solution, which I think is pretty cool. There's a question here I wanted to call out. So how would policy as code or approvals tie into this? I actually think I have a diagram showing that I can share. But Yeah, basically, if you are running preventative policies, so these are policies that will actually stop before you actually create the resource, then the preview will catch those and stop them. And I think that is probably the most useful way to have policies in the pipeline preventing things. Does the Pulumi provider for GitHub support managing GitHub custom properties, teams, and create policies? I don't actually know. The GitHub provider can do a lot.
Yeah, I don't know that off the top of my head either, but it does. You can do things like create branch policies and things of that nature.
So a question I wanted to ask you, Zach, is, wait, I wrote this down. Like, how do you compare Azure DevOps with like GitHub Actions or GitLab or other solutions? Like, where would you prefer one over the other?
They all have their strengths and weaknesses, I'd say. I've used all of them at this point. I think where I get the most like joy out of Azure DevOps over others is that a lot of other solutions are very, very container driven, which is fine because you get like one step is one container. It's perfectly isolated, but it's hard to sometimes logically think through. I have a prep step, like a if let's say take for example a C# thing. You want to do a build. You want to do a build artifact, and then you might have a different step that does the actual deployment into your Azure functions, or run some infrastructure steps between those. You want to have a build, then some infra, and then a publish. The way that the runners in Azure pipelines, Azure DevOps work is like you basically have one runner locked, and it runs those steps in sequence. So it's very, very easy to understand. Like take what you might do on your local laptop. I run this step, I run this step, I run this step, and then that all kind of works. That's very translatable to Azure Pipelines runners that are literally just running those commands in order on the same host all the time. Whereas some other CI providers, like their step isolation, which is good and bad, but it can be very struggling when like I've got to build artifact. Now I've got to grab where that archive lives. I've got to publish that as a pipeline artifact so that some other future step can pull it down, and then add environment variables or run some infrastructure and then redeploy it. So some of what I think is good about Azure DevOps in general is just like there's a runner, it'll run whatever you want. If you do want different runners or you do need those things, you can break them into stages. So where you have like a very clear delineation, there's just a little more control over how much you'd want to do in one pass on one runner, but still have it logically separated in the UI where you can see distinct steps for failures and logging and whatnot.
Nice. One of my like tricks I would always use is to try to keep as much logic as possible actually out of the pipeline definition and put it into into PowerShell or Bash or something, so that I could, to my best ability, run it outside of the CI pipeline just to kind of debug it.
Mm-hmm.
Yeah.
Truth be told, I found that more and more. That's actually what I end up doing. Is like, there's certain frustrations and limitations, I think, in all of these tools where at the end of the day, I just kind of want to run it as part of like I'd start building my own programs and whatnot, which is part of where resource hooks with Pulumi actually does start to come into play, because you can very easily, as part of your infrastructure step, run anything in those steps, really. Like local CLI, you can inject anything you want in there. And that sort of helps bridge where I just want to write a program that does this kind of thing.
Yeah. Somebody here was asking questions about the resource hook blue-green deployment. Zach, you shared a link.
Yep.
Yeah, the hooks are pretty cool. You can, I forget what the different events are. You can hook into before create, after create, before update, after update, before delete, after delete.
Mm-hmm.
And go ahead.
Those lifecycle hooks. I've got some practical experience in AWS where AWS has like app features, and so you can use like feature flags and things, but it has some weird rules around like you can't delete a flag if it knows something is using it. So you first have to then write some like queries to see if the flag's in use, and then find whatever's using it and disconnect it, and stuff that's not exactly easy from an infrastructure as code pattern where the apps that might be using that feature flag could live in totally different projects or anything like that. So it gives you that flexibility to where, like, before delete, query for your things in use, disconnect them or change them, and then the delete will happen, and then you don't get this like lifecycle catch-22 where I want to delete a flag, but I have to go find every weird app that's using this flag that I stood up. That's the ability to kind of just do some raw API calls if you want. That's all kind of available inside of the Pulumi context.
Yeah, I found it pretty powerful. So the blue-green thing I was mentioning, what I ended up doing as, I think it was maybe after create, but yeah, you can hook in wherever you want. And so I could hook in there and do a health check, right? To say like, oh, we're not actually done creating it until like the health check responds, which was pretty useful.
Yeah. Good use cases around SQL databases and things as well, right? You use your infrastructure to provision yourself a new database, but then you would need to write some like raw T-SQL to create users or perm users like at the database level. You can put that into a resource. So after create, run the user provision actual raw SQL with like an actual connection to that brand new resource.
I feel like the only challenge with it is like, maybe you don't want to reach for it too often. Like it's like, it does feel like a power tool. Like,
yeah,
this update is going to get quite complex. So another question I wanted to ask was, did you have any struggles like with having a fast pipeline, like quickly deploying things out and having like a safe rollout where you're doing lots of checks? How do you balance these two things?
Some rough rules of thumb there. I don't know if they're even necessarily industry, but if I find a build that's kind of etching north of 20 minutes, you move through whatever tests, or it's got to do multiple environments or whatnot. That's sort of a rule of thumb of like, once in north of 20 minutes, I want to start to, can I parallelize some of this work? Is all this work necessary every change or just certain changes? And so that's kind of where splitting that down or breaking that down, having the ability to run certain things only in CI, only in IaC, it gives a lot more tools to kind of solve those kinds of problems. Because at the end of the day, the workflow from an engineer, most engineers is like, they push to change. They don't really care if it's infrastructure or app change. Like they just want it live as fast as possible and as safely as possible.
Yeah, it's like the ideal like CI/CD process. Like you'd never hear from it because like it always works. Like you never just, oh yeah, no, it worked. Yeah. So have you had experience with actually like making infrastructure changes approachable for people who aren't the infrastructure engineer?
Yeah, a lot. So and part of platform engineering, our approach in some past lives was just to give as much opinion as possible. We really tried to get it to a place where the engineers didn't even need to know what cloud it was deploying to. Like if you're going to build a front-end app at my enterprise, there is a set of Pulumi ESC components that basically say front-end app. Put your node build commands in there, and then the pipeline will take care of the rest. And it's going to provision it. And then the stack output was the URL of your new front end. And so then like your CI/CD process, like, okay, here it is. Here's my URL. If it's a preview, like, comment that there was actually a bot that would comment on the PR. Here's your new test URL. And then on merge, like there's the resulting URL. And it was always there, whether it was ephemeral or not. There was either a dedicated environment or an ephemeral stack that was like tied to a PR. So being able to build those kinds of things in, like, there's a lot of compliance, there's a lot of checks, there's a lot of processes that are going into that, but also the engineer isn't really, to your point, they don't actually care. Like just they commit and they're waiting for a temp URL so they can show a designer, here, I move the button, from the right to the left. What do you think? And like, yeah, approved. And all right, now it's live. Stuff like that it's really what you want. It's the experience you want to try and shoot for.
Now, what if they're doing something that's like outside of the box though, right? Like they need to actually have something specific happen to the infrastructure as part of their change. Like how does that work?
The IaC gives that capability. Like our components had exports for certain things, so that if you did want to extend it, there was always a variable. Like the component class would have outputs of URLs of whatever bits of infrastructure. So let's say you wanted to create a dedicated microservice, but you also wanted to add permissions to a database or something upstream. There was at least, always export your identifiers, your ARNs, or things of that nature where you could feasibly layer in more infrastructure as code. So like our boilerplate would give them like, here is a web app, here's a microservice, here's a web app, here's a whatever. But those objects have enough connectors where if you wanted to then go and write more infrastructure as code to extend that, there's nothing to stop you from doing that.
And did that work? Like, was there uptake on people contributing infrastructure changes that way?
Yeah, big time. I mean, I think once you get an engineer that, okay, I've got my Hello World app, like now I want to do X, like how do I start to kind of dig into that? And like, just success begets success. So as long as you make it easy and approachable to kind of get started, people are pretty ready to extend it.
See, I think that's the I don't know what's my word. That's like the ideal, right? Like, I feel like whenever I ask people and they're like, yeah, no, people are contributing. People who wouldn't get their toes into the infrastructure generally because it was difficult. Now they have raised changes and it worked. And yeah, as you said, success begets success. Like, it really changes the game. I think that's my opinion. Let's see what other questions we have here from the group. So any challenges that you've had in the past with identity or authorization that you think would be worth sharing here?
The person that called out policy as code earlier, I think there's a big policy launch coming, I think tomorrow, of pretty massive just improvements in general about that visibility and whatnot. So that's the other piece of it, is that if you don't have that platform engineering team that's giving you a boilerplate, like here is your back end, or you want to start to extend it, it's difficult for engineers to know that they're doing the right thing, and so that's where Pulumi policy comes in. Like, yeah, you've added a role, you've extended it, but you gave it, overly permissive. If let's say it's AWS, you gave it an IAM role where you give it a star.star, something like that, and all you really needed to do is give it like a web thing. For engineers that are in the moment of things, like they don't necessarily, they just want it to work. They don't necessarily care too much about those types of things. Like, it can be very frustrating to try to dial that in. You're worried about this functionality of your application and you want to test that. You don't care about the permission role of it so much. So you'll grab whatever first example, it looks like it should work, you put it up there, it's great. And then in the old world, pre-policy, you would have a security engineer or some scan from some tool months down the road that would come back and be like, this role that you added, that's not okay. And I think the policy packs, you get your Pulumi preview, you get your Pulumi up, you get that feedback immediately. This is an overly permissive role. And it's through custom packs, through standards like high trust. Like, there's a lot of pre-built stuff in there, so you can just turn it on, and then if it shows red, then you're doing it wrong. But you get that feedback immediately, like while you're working on the problem, which I think that's a much more empathetic process than kind of the old world where somebody was chasing you with findings because there's some audit going on, or some security tools found something that you hadn't thought about for months.
Yeah, I totally agree. And it's a different experience too, like, because you can author these and it's actually not that hard. Like, there's a lot of ones that come off the shelf that can be pretty powerful, but like, it's also useful. Like, I think of it in terms of that, like unit testing, like red, green, refactor. It's like, oh, if there's a problem, right? We find some problem in our cloud, we shouldn't have allowed this. Like, we can then like just author a policy so that we don't let this happen in the future. And like, that becomes pretty powerful. So it's not like, hey, what do we do about this in the future? Like, oh, well, we'll just be vigilant. Like, sometimes that's the idea, right? Or yeah, we'll have somebody do an audit every so often. But no, like, we can just describe what we don't want to see and enforce that, like, ongoing, right? That's amazing to me.
Yeah, for the Azure crowd, let's take the example of like web applications. So you always need like an app service plan. And app service plans can be any size or OS level you really want. There's a lot of power and flexibility in that. One of the things that we had done is to set a app service plan module where we basically made like 3 basic sizes that we felt our organization could tolerate. Here's your cheap one, here's your mid tier, here's your high tier. And then the Pulumi policy would be, just ensuring that the parent of whatever created an app service plan was our module. And that way, we didn't have to worry about any number of combinations of languages, OSs, everything Azure supports. Like, as an organization, we really only want to think about like 3. And so we'll put those in the component. If we ever decide we want to add a fourth or a fifth, like we just add it to the component, the policy, all it has to worry about is, was this created using our custom component or not? And then you get that rail where an engineer they might try and extend it to create their own app service plan, but it's not using a shared one or a shared resource or a certain size or OS. And that gets flagged immediately based on your organization's rules.
Yeah, policies they're pretty powerful. They're hard to like sell people on because it doesn't sound exciting, like, oh, enforcement, but like really you can really change the game, because if you can enforce these things, then you can allow more freedom because you have these guardrails. Yeah.
Exactly.
All right, so this was the talk. Make sure to join us in the Pulumi community. So join the Slack, say hello. This should be updated, but there's an Azure community. It's quite active. Zac's in there answering questions sometimes. Check out Pulumi Neo. So once you have something like this built, one of the other great things is like its infrastructure is code, and coding agents are quite good at writing code. So you can get some help from Neo or your favorite Claude Code or VS Code. But Neo is pretty amazing. Yeah, so thank you. Thanks, Zac, for coming along, and I hope everybody enjoyed this. Yeah, let me know your feedback for next time.
Thanks so much.